I will present together with Nicola Sander a joint paper with Guy Abel and Johannes Schmidt. Nicola, Guy and me. We are working at the Vienna Institute of Demography. That means we are coming from the research area, looking from this perspective on data visualization. So we will hear the perspective of the researchers when doing a data visualization project. So the main part of the presentation that Nicola will present later is about a research-driven database project we were doing at the Vienna Institute of Demography based on a new data set of international migration flows developed by Nicola and Guy. But before coming to that, I will put the scope on this perspective, how researchers view science communication, especially with data visualization. So we'll discuss first the state of science communication, very briefly, the role of data viz, and also the precondition or prerequisites for scientists so that they are able actually to inform the public or even better to engage with the public. So let's start with the state of science communication as a point of departure. The traditional way, and this is still the contemporary way of doing science communication, is to come up with a pile of numbers, often in a tabular form, and a pile of text. However, when coming up with numbers and text, it's usually very hard to understand for a normal audience, let's say. Normal audience, why? Scientists are used to talk to each other. They're normally their own audience. That leads to a gap between the science and the public. And we think that data visualization can bridge the gap between the science and the public. So the focus now is why do scientists fail to communicate with the public, and how data viz can help to improve the situation. Starting with science communication, first it must be stressed that there's quite a late transition from traditional to digital dissemination for scientists. They are kind of latecomers when using the web and other technologies when communicating their findings. That might be also the matter because we have a different business model. That brings me to the barriers to communication when scientists try to communicate their findings. What's the problem? Actually, they don't get paid for doing outreach. We earn our points when coming up with high-profile publications, and that points, they bring us tenure, new funding, and progression in our careers. Another point is that there are some persistent stereotypes of scientists when they think about the public. They cannot imagine normally that they understand what they are talking about. But that might also be a matter of communication. Bottom line, scientists lack the skills to communicate, and when we aim to communicate our scientific findings to the public, or even better to engage with the public, it needs a cultural change, a change in attitudes. We have, when we try to come from the point of informing to engaging the public, and with engaging we mean any form of interaction where scientists communicate with non-scientists, we have the problem that science is something like a gray box. Nobody understands what's going on in there, and of course it would help if science could open up the scientific process in general, so that would lead to more engagement with the public, and would also motivate the public to get also engaged with scientists. So nowadays we already speak about open access, open data, and also about open source. And this is already gaining some momentum. So we have that already in our research process, but it's a slow momentum still. At the end of the day, it would be great to speak about something like open science in general, which would foster the accessibility of the research process for scientists and, of course, also for the public. What is the role of data visualization in this context? How can data visualization bridge this gap and encourage engagement? Here just a few points. We all know that data visualization attracts visually, so we get the interest of the audience. Data visualization presents and represents data. It allows insights, and thus it also facilitates the accessibility and the understanding of research findings. And by amplifying the cognition, it allows users to go deeper into the data and into the topic, so that the audience actually become the user, make something out of the data visualization, his or her own stories. What is the problem? Moritz Stefaner, here's a very nice quote, he put it right. Scientists do not seem to distinguish between analysis and communication. So the problem is the last exploratory graph becomes explanatory. So we talk to our own audience normally, and when you go to especially social science conference, you quite often see charts like that. So during the process of exploring the data to find out something new, a lot of charts are produced. However, the last chart will be presented so that you can normally not see anything about it. It's too small. Here it says things increase. There is no annotation, there's no highlighting, there's a mess with the legend. Coming back to the fact, scientists lack the mind and skill set to communicate data visually. So what skills do we need to engage visually with each other? That also relates to the public side, not just the scientific side. We need a diversity of literacies. And when speaking about literacy, it's not just linguistic literacy, it also comes to the denotation of data and visuals. So we have data literacy to make the use of quantitative information. In this context also, it's necessary to have some statistical literacy to make sense of statistical information. Scientific literacy, of course, scientists should be scientific literate, but it also helps if the public has some knowledge about scientific process. And of course we need visual literacy to communicate to each other in a common language, to construct some meaning from visual images. And nowadays, of course, media literacy. We might add a few more literacies, computer literacy, programming literacy, and so on. To sum up already my rather theoretical part, I will use a concept from social scientists to make clear what is actually needed for scientists to engage with the public. Here are some preconditions required to adopt a new form of behavior. So it's not enough to be able to have the ability to communicate data to the public, so it makes sense. You must be also ready and willing to do so. So readiness means a new behavior must be advantageous. Willingness, a new behavior must be culturally acceptable. And the ability is rather technical and social means for the realization. And when bringing that into the context of scientists communicating to the public, it looks rather like that. Readiness means why researchers should engage. They have to be clear it's their duty to engage with the public, to communicate. It also would increase the value of science in the public. To be ready, it needs a change in our job description. Since we, as I explained, we are not paid for doing that. Being willing means what does it bring for us? We have a lack of incentives in scientific process. And to change the mindset, we need some institutional incentives and also an environment to communicate our data visually. And last but not least, the ability how to do it. Here comes in all the skill sets that are lacking actually, and the skills that we lack, they are a lot. Coming to the quote of Andy Clerk, data visualization is a multidisciplinary subject, and this is a metaphor for the different mind and skill sets that are necessary to do a data visualization project, be the initiator, the data scientist, also the computer scientist and the designer. The last two, the latter two, normally no hats that scientists are wearing. So, as long as we don't have the ability to do it, even if we are ready and willing to do so, we cannot wear all these hats. So, what is the solution? Actually, to team up with experts. That's what we did in our project, in our database project, and that's what Nicola will present now. She will talk about the background of the research we did, and also the data, and so on. So the floor is yours.
Yeah, thank you, Ramon. Okay, so the project, basically in the outreach and the dissemination, we called it the global flow of people, and it's about human migration. And if you think about human migration and what you've been picking up in the press and popular press and others, and generally, quite often, in the case now with the Mediterranean refugee movement and everything, it's about mass migration. It's about continuously increasing immigration to Europe and globally, and it's all very dramatic. The problem is that to make actually that statement, you need a longitudinal kind of a time series on the number of people who move over a given period of time between countries. And we don't have that data, or we haven't had that data so far. And we probably never know the true number of people that are moving in any given minute. The problem is that there is flow data on migration, so the number of people changing dynamically, the traffic basically of human movement, but it's not recorded by a lot of countries globally. So the UN probably has assembled around 50 or so countries, published the data, but countries measure migration historically in all different ways. So some use a census, some use a register. They define it differently, they have different time periods. So it's all apples and oranges. And the only existing data that's been harmonized is basically for flows within Europe. But if you look at the global level, the flow data is very patchy. What is more widely available are data on so-called migrant stocks. So that's a snapshot, mostly taken from population censuses, where you catch the immigrant population, so the country of birth differs from the country of current residence, but it's just a snapshot of a given point in time, and you don't actually know when people moved there. But people have been using this in, for example, the People Moving project. They've been using these stock data, and because it's sort of a difficult terminology with migration, and there are many different concepts, they've been calling this a flow, but it's actually just a lifetime measure of between country of birth and country of current residence. So it's a bit of an iffy concept to call it flow. And the seemingly simple question of how many people migrated in the world between, say, 2005 and 2010, we actually didn't have a quantitative answer to that so far. This might be quite surprising, but this is the state what we were at. So what we did in this research project that Ramon already mentioned is that we took these stock data that are quite reliable, there are relatively little issues with harmonizing them, and estimated using a statistical method. A colleague who was a social statistician estimated these flows from the stocks. So on the input data, we have these United Nations data. These are lifetime data. This is a static snapshot for more than 200 countries and for 3 points in time. And then we get the dynamic flow over 5-year periods between 196 countries. There's a gap because we didn't have demographic data for all the 220 countries. And I just want to give you a brief overview. I don't want to go into the statistical details. There is a paper, got a printout if you're interested in the hardcore methodology, but just want to give you a snapshot of what the data look like. So these are the stocks for 4 hypothetical countries, A, B, and C, D. You have the country of birth in green. So the green sum of the column of the row totals are basically all people who were born in a particular country and who are now scattered across different countries of residence. And in the columns in orange, you have the country of current residence. So the diagonal is basically the native population that is still in their current country, in their country of birth, and all the non-diagonal elements are the migrant stocks, people who live in a different country than they were born. Now, the flow data that we were estimating looks a little bit different. You have an origin and a destination. You don't have any diagonal anymore because that would be the stayers who didn't move. You leave them out. We're only interested in the off-diagonal cells, and these are actually people who move from an origin, say B, then 35 people who move from B to A over, in this case, a 5-year period. And then if you do basically get this as output of our research project for 196 countries, it becomes quite a big matrix. And if we sum up all these non-diagonal cells, we get the global number of people who moved over 5-year periods across countries. And if we sum that up over the 4 time points and time periods, we get roughly 0.6% of the world population who have been moving over 5-year periods. And it's quite a small number, actually. 0.6 corresponds to about 41 million people. It's been slightly higher in the first period of the early 1990s, mostly because of violent conflicts in Rwanda and Afghanistan that triggered a lot of movement. Also the fall of the Iron Curtain. It all calmed down then and has been mostly stable since then. So there isn't really a rising tide of migration according to our estimates. But this is only the global view. And if you want to look at particular flows between countries, to look at the pattern, what demographers usually do is they do a table. It doesn't get us anywhere, really. Okay, so let's look at what's been doing historically to visualize migration flows. There's a seminal map from Charles Joseph Minard. He's already put in some color coding. He's done sort of lines between origins and destinations, the colors to denote the origin and the destination distance. So for the mid-19th century, that was already quite nice work. And what's been quite frustrating is what happened over the last 150 years, because not really that much of an improvement, I'd say. So this is a typical flow map, just pulled off the internet. What you usually have is, GIS packages, whatever. You have an arrow that's drawn atop of a map. And of course, it's not really visually attractive, and the complexity is somewhat limited, so I thought, okay, I have to find something else. So Googling one night, I came across Circus, which is originally developed by a Canadian genome researcher to visualize chromosome mutations. And I thought, hey, what about, if we just ditch the map? And 1.5 years later, we arrived with what we call a circular migration plot. And so this plot basically shows our data aggregated at world region level. Each world region is assigned a unique color and is represented by a segment of the circle. And the length of the segment represents the total volume of migration to and from that region. So North America, for example, is colored red here, and all the outflows from North America are also colored red, and they mostly go back to Europe. So these are European settlers who are returning home. And all the inflows are colored, from Mexico, for example, are colored in a different country, in a different color than the destination, and there's also a gap between the destination end of a flow and the segment to which they move to. So the big advantage here is that you can show all the flows in the world in one image, and you can directly compare sizes of flows between each other. And that wasn't possible before because the data wasn't harmonized. But here we can actually do it. And so you see, for example, this big flow within South and West Asia down the bottom in blue, which is considerably larger, for example, than a flow from Latin to North America. And that surprised a couple of people. Okay, and then we had this visualization and we had the estimation, and that actually allowed us to publish our work in Science, quite a well-known journal. And then we thought, okay, it might be worth disseminating that a little bit. And in the Vienna Institute of Demography, the flagship dissemination project is this European demographic data sheet. People like it a lot, they're quite proud of it. It's very popular, gets updated since 2006 or 2008. And we did something quite revolutionary because we thought, let's change the numbers for graphic. There were quite some discussions internally whether we could really do this. You know, people would be expecting a table from a demographic institute. But it turns out they're actually quite happy to see something different. And we've now, got requests from teachers, from company people, from a really diverse group of people who wanted to get a hard copy of this. So it's quite nice to see. And then we didn't stop there. We thought, hey, there is actually Mike Bostock's great D3 library, and there's the Coale diagram. Let's do something interactive. And that was, of course, beyond what we could do. So we teamed up with a company in Berlin that did the coding and a graphics designer who did the page. And we created the website that is now online. It's called The Global Flow of People, where you can explore the data interactively in the chart, but you can also download the data, you can download the data sheet. So we're really trying to make everything open and accessible and reproducible. So let's take just a quick snapshot of what the data or this chart looks like. So you have three basic elements of interaction here. One is you can hover over it to highlight individual flows and look at the tooltips to get the actual number of people moving. You can click on one particular segment, and that then opens up the region into the individual countries. And you can open two at the same time. And if you then want to open the third one, it closes the second one again. So sort of give every country enough space. And then you can look at how this changed over time. So you can go back in time, and the chart updates automatically, drawing from our estimates that were published in the paper. Okay, so we got the paper accepted, we got the website ready, and then I got a call or email from Science, from the publisher, saying, we're expecting some heightened media attention to your work. And I got a bit worried, because normally when you have a migration research project that's going into the media, you get a slide like this. And I didn't really want to go into, having to deal with Daily Mail and sparking any of that sort of stuff. But luckily, it turns out that the responses were quite positive. And this is one of the first pieces that came out in Quartz, which is The Atlantic, basically the business digital native magazine. And Nick Stockton, I must say, really, we have to thank him. He did a really great job of really engaging with this topic and researching it and getting third-party comments on it. And he embedded this chart from the data sheet and also included the interactive bit in it. And so that story and a couple of others then caused a couple of tweets. And here is the one that got it started, where everyone in the world is migrating from the Quartz Journal. We got a couple of retweets, and then we got some really nice responses. For some reason, Twitter doesn't allow you to actually show this embedded thing in a bigger font. I don't know why. So, fantastic visualization of global migration flow data. I'm on there if you zoom in a lot. So people actually started engaging, and I thought that was really cool. And then an eye-opening and beautiful executed visualization on migration after the data can be downloaded. okay, there is actually appreciation from not just peers but also the wider public on making things open. And then people started to reflect and they said, well, very interesting, pretty and thought-provoking too, puts the UK tabloids, Rands, into perspective. So that's great, people are actually engaging with it, they're reflecting, sort of comparing it to what they thought before. And the same with, Jacques from France saying, please someone tell Marine Le Pen, African migrants are invading us, and here's the data to prove it. So again, there's this engagement and there's this reflection, and we thought, okay, what nicer could be happening, These people are more likely to actually not freak out the next headline they see in a newspaper and say they're going to be run over by immigrants and vote for the right-wing parties. And we got also a lot of tweets about, hey, it's not actually the poorest who move the most. And I thought, okay, that's an interesting thought. And then Mark Fischetti and Jen Christiansen from Scientific American emailed and said, hey, do you have some sort of sub-story? And I thought, yeah, of course. Twitter's told me not the poorest who migrate the most is interesting, so let's just visualize this. So we got together with Mark and we wrote a really nice piece about it, spread further. The ILO, International Labour Organization, called, these are policymakers, and scientists are really interested normally in getting the policymakers engaged. We didn't actually target them specifically, but it shows that if you reach the public, you also reach the policymakers. And they then embedded that chart into their report for the last international conference. And we also have a couple of spin-offs now, since we made it all, the code and everything, and the custom library for actually creating this chart openly available. Had a couple of spin-off projects. We're working on a visualization for UK migration data. This is an example here, which is online for data in Germany, for example, which uses the same library, a different data set. And there are a couple of spin-off projects now, and we're sort of trying, okay, how can we extend this visualization and improve it? And this is a great conference here to get further inspiration, actually. So to summarize everything, slide continues to move. Just a second. Okay, conclusions. I think using data visualization in our case to engage the public actually worked. But teaming up with experts outside the academic group was essential. And we had quite positive feedback, which was really encouraging actually, not only from the peers, but the public and a lot of other groups, so that's great to see. The question now is, how can we get other researchers not just to like it, but actually to take it on and improve engaging the public using visualization, engagement, the web. And there, Ramon already mentioned, okay, there is a mindset that we need to change among the research peers, and there's also a skill set we need to address. And this mindset that people can team up with the outside world, with journalists, with coders, to actually get data and the research more out there. And I think, so the concluding sentence would be, okay, data visualization has the potential to bridge this gap between science and the public. We just need to make it happen. Okay, thank you.
Okay, we have about 10 minutes for questions. Nicola or Ramon, there's a question in the back there. Can you state your name?
Sure. My name's Jeremy Walton. I'm from the Met Office. I like your idea of teaming up, of forming a group of people who can do different aspects of this problem. There's just one aspect of that I'd like a little bit more detail on. Did I get the impression that for making the static version of this visualization, you did that yourself, but when you wanted to make it interactive and web-based, you had to pull in a web designer, and you had to go to a development house, so you knew how to use d3.js. Is that correct?
Yeah, exactly. So the Circus software, which is also freely available, it's a Perl script. I managed to actually get that working in-house. So this data sheet and everything that was produced by us. But then when it came to the D3 coding and the HTML and everything, okay, this is out of the scope.
Right.
And then we teamed up.
We teamed up and we were jointly developing also the interactive plot. So it's not that you're just asking for service and pay some money. So it was more a partnership.
Right.
Also when developing also the one-pager website of the global flow of people, where we also give access to the paper. Even the science papers, they are free access, and we have the data online, and we also have a link to the source code, so other people can use what we, together with 02, what we developed interactively. So, and, yeah.
Thank you very much.
Yeah. Okay, question up here.
Hi, Rosemary Hill, University of Leeds. I was wondering why, when you used geographical locations in most of the areas, like Southeast Asia, why you used former Soviet Union for North Asia?
Mostly the grouping was based on the United Nations geographies, the regions. But we figured out that the countries of the former Soviet Union were really different, and we didn't want to put them together with the rest of Asia. And we didn't really want to put them together with Europe, because there was this effect of the fall of the Iron Curtain. So I thought, okay, to not obscure, the European or the Asian, it's actually quite nice to have it separate, because that was also quite surprising that this movement within these former Soviet Union countries were actually quite confined. There is relatively little movement out and in of that region, which was an interesting fact to point out, which wouldn't have been possible if we had merged it with other regions.
Okay, question down here.
Neil Kay.
Can you speak a little louder?
Neil Kay from the UK Met Office. The order of the circle, then how do the regions or countries appear? Is it a random approach, or is it significant that Africa's next to Europe, or Africa's somewhere different, or is it, how do you decide where all the countries and regions go?
In the circle,
Yeah.
you mean? Well, that's kind of a little bit on geographic proximity, but also there's a lot of visual judgment. So the whole circular migration plot and using circles and the interactive bit, it wasn't like data set in, pretty plot out. There was a lot of mind work and judgment and visual sort of elaboration to actually make it easily understandable. There are a couple of other applications of like the core diagram online, but some of them are not as intuitive and accessible, because I think there's this extra step of the design process that's necessary.
Any other question? There's one down here.
Sorry, to pick up on my last one. So the control is purely how you felt about these things, to the order of the countries? Because longer lines that cross the whole circle look very dramatic and will lead you to a certain interpretation.
Yeah.
Whereas if they're just hopping to their neighbour next door, there's less of a story visually, because you don't see it as much. So what is the control? Is it you?
Yes.
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 In the end, it's us.
We didn't even try to represent the geographical situation of the globe into a circular plot. We would have failed anyway. So it was us, our intuition.
Okay, question here.
Hi, I'm Andy from Tableau Software. Did you look at any other visualizations, or was it just the circular type?
Well, I've looked through all the, Geographer and did some GIS before. I looked at all these plugins and S3 and what they provide. But was a bit disappointed, really, that the GIS community hasn't taken on that. And there are a couple of new developments now we didn't show, for example, with the Washington group, which now moved, former Stanford, the VIS community, and they had a visualization as well, but they're all sort of focusing on a map and a geographically true map, not an abstract map, and they're all run into the same problems. And I'm thinking now, okay, one way to actually change this is to go into a very abstract geographic representation, to try that out, to see if there's an alternative to the circular representation. But basically, I did search for alternative methods and nothing really did strike me as, yeah, it's the optimum solution. And this probably isn't the optimum solution either, so we're still searching.
Question up here?
My name is Daniel from the German Statistics Office. One question I had is the arcs of, say, Europe or Africa represent the in and outflow, the value of the in and outflow. Is there any way, did you ever discuss sort of looking at how to distinguish between how many people are going in and how many people are coming out? I mean, I know you can, I just mean visually, when you look at it straight away, you can't, it's difficult to see immediately how big is the, influx, how big is, do you know what I mean?
Well, these are actually not net, they're the actual A to B flows.
Yeah.
So you have a flow from Latin America to North America, and you have a small return flow, and they are separate.
I just mean, if you, the part of the circle that's Europe represents in and outflux.
Yes.
And it could be that much influx and that much outflux. Do you know what I mean?
Yeah.
It could also be the opposite, but it wouldn't change the...
Yeah,
Okay.
you see the volume, but you still have the arcs
But they're
to
also,
see the different flows.
yeah.
You see.
Yeah.
But they're also sorted. So you have all the inflows first, if you look at one segment.
Yeah.
You have all the inflows, and they are sorted by their size. So you have the largest inflow
I just mean
first.
distinguishing between...
There's that black gap.
Yeah.
It's the gap that
Yeah,
tells you
yeah.
whether they're going in or
Not
not.
there at first, but
In the segment itself.
Within the segment showing how much of it is, just
Yeah.
giving it a little mark, how much is coming in. I understand the graph.
It's the black gap.
Yeah,
that
gotcha.
tells you
Yeah,
whether
good
it's
idea.
going in or
Yeah,
out.
thanks.
Yeah, but how do I know is in or out?
You,
The black gap, yeah, I get it.
Oh, yeah, I see.
So if
It's
the object is out,
It's not obvious.
it's in because where there's not a gap, it's clearly going out because those are going out of Europe.
But exactly this is still the point of discussion also internally, how to improve the direction of the flows.
Yeah.
We tried a lot, having the color fading, and I don't want to tell you how it looks like if you bring motion into it, it's too much. If there are some hints that we can take home with us, we might discuss this also in the evening and on other occasions.
Yeah.
I think the Europe is a good example. Like the amount coming in is quite large, and the amount going out is quite small. Yeah, can you see what I mean? The
Yeah.
black section of the green is fairly big compared to some other. It's just interesting. It's difficult to see at first sight.
Yeah.
You know what I
Yeah.
mean?
Thank you.
okay, I think we need to end this